Yeah, I started recording.
Hello guys, welcome to the online meetup of Litmus Chaos Community. What we can do today is start with the agenda. Let me share my screen. So we have some interesting talks going on. And we did really release a great release on the 15th of this month with many features coming out both for developers and SREs. So we're going to have some nice demos around that. But just for an introduction, I can just quickly talk about what is Litmus and the roots of it, all that stuff, right? Maybe I can pull out the presentation that we did last year to the app delivery SIG of CNCF, right? So at the outset, currently this project is owned and sponsored by Data, but we're in the process of donating Litmus Chaos to CNCF so that there is a vendor neutral home to the project. More wider participation comes in the form of developing the code, usage, and feedback, all that stuff, right? So this is the website. You can see that it's a completely GitHub hosted project with Apache 2 license, which is a primary requirement for getting into CNCF. This is a 100% open source project with all modules under Apache 2 license. Let's see the chat. And we have a large community. As you can see that the number of contributors have increased beyond few. Data itself has around 15 to 20 contributors, but there are more contributors coming into the project from outside. And where we are today with CNCF sandbox process is we have been cleared by the app delivery SIG to be accepted as a sandbox project. So we're waiting for the TOC sponsors. So it will be a few more days before or weeks before we are formally getting into sandbox project. So primarily, we started this project as a way to deliver a complete end-to-end infrastructure to carry out chaos engineering, right? So in order for applications to be deployed and validated, and to make sure that there is resilience in the deployments before the delivery and after the delivery, you need to practice chaos engineering. And so that's exactly where the original goal came in from. And we started doing this for our other project of EBS, and then we later extended to the entire Kubernetes community. And using Litmus, we can do resilience engineering or reliability engineering or chaos engineering, whatever you call. But primarily, you start injecting faults in a cloud native way, right? So what do you mean cloud native way? Cloud native way, to be to honest, we can say it as Kubernetes native way. That's how it has become, because Kubernetes is the most dominant way of doing anything related to cloud native engineering. Right? So what we did when we wanted to build a cloud native chaos engineering is we defined some standard CRDs and an operator to deal with those CRDs and a chaos hub. And once we have those things, it's a matter of just create another Kubernetes object, right? You want a PV, you create an object. You want a service, you create a specific kind. and you want to inject chaos, you define a specific kind called chaos engine, and then induce chaos experiments. And that's how it started with. And then later, we also extended this to include workflows, right? In real chaos engineering, it is not enough to do an experiment, that is, kill a pod, kill a node. No, we need much more than that. What it means is I need to be able to do a sequence of faults and then be able to observe what exactly is happening. Is my reliability there? An example would be, let's introduce some delay into a subnet, network subnet, and also pull out some disks and then kill the node and then increase the application workload, right? How is my service doing? That's reasonably okay situation to expect to happen, right? So how do you do that using Litmus, right? So we started using another CNCF incubating project called Argo, and we are now combining Litmus Chaos and Argo to create chaos workflows, and that's where we are today, right? So and the Chaos Hub is a community centric hub where everybody comes in and upstream their experiment that they've written or download the experiments that are already available, right? So let me show how many of them are there right now. There are quite a lot. There are about 12 ways to inject fault that are specific to Kubernetes. There are many application specific chaos, either OpenEBS or Cassandra or CoreDNS, Mongo, Longhorn, etc., etc. So we expect more and more applications to come and develop the experiments using the infrastructure that we provide, and then donate or upstream their applications so that they are available for a large audience. So that's a primary introduction, a very quick way. Sorry to barge in and give a little bit of a different agenda. Now we'll go back to the original agenda, where we have introduced some 3 to 4 big features in 1.4 release, which went out last week. And one of them is being able to induce Litmus Chaos experiments through Github Actions, primarily for developers. And also, we have introduced Scheduler. And then there is a observability detail from coming in through Grafana. And most importantly, we also have introduced the Go-based SDK, right? So these are the 4 major features, and we're going to have detailed discussions around them from our team and speakers. So with that, I will stop sharing and then give the stage back to Udit.
Thanks, Suma, for the introduction. Udit, we can take over.
Hi everyone, I'm audible.
Yeah, little bit more voice will be better, Udit.
Okay, 1 second. Now it's fine.
Yeah, it's better.
Yeah. In this demo session, I am going to show you one of the features that has been added in 1.4 Litmus. Let me share my screen first. 1 second. Actually, I'm unable to share my screen. Host disabled participant. Now I can.
Hear it now? Okay, great.
Yeah, so in this demo session, I will show you one of the features that is added in this release. That is that is actions, GitHub Actions to run the chaos experiment on the review application. So those who are not aware much about the workflow GitHub Actions, just introducing for them. So this is nothing but a CI platform. In the GitHub itself, you can have a directory GitHub workflow and can have your custom YAML files which will be running according to whatever you have mentioned, like whatever basis, like pull request basis or push basis on some particular branch. Just mention that, and we'll have some workflows are nothing but the sample sequence of commands which you can give to test the deployment or whatever your need is. And we can introduce some actions in that using uses. And here comes the Litmus GitHub Actions. I am just introducing Litmus GitHub Action, and to perform some chaos experiments. There are a number of chaos experiments, and in this demo session there are 3-4 steps I will just perform, like creating a cluster. For this demo session only, we can have a attached cluster in the real scenario as well, and then we will deploy an application. Then I will set the config file, and then I will perform the actions, and then at the last stage I will clear everything. So let me make a push to this so that it would trigger. So I am here right now. The go. Okay. So right now I'm using Mayata.io GitHub Chaos Actions, and I just want to perform a pod delete experiment. And these are the environment variables which will be required for the experiment. That okay, I want to run the experiment for 30 seconds. The interval will be 10 seconds, and it should not be false. So, and before that, I just want to install the Litmus, and these are the application details which you will be giving here, on which the chaos will perform. So just provide these values, and we will have one push on this. Yeah, just a sample push I am doing here just to show the workflow. So we can see that that makes this workflow triggered. Yeah, so these were the sequences, and this started building the image and running the workflows. So it will take some 2 to 3 minutes in creating a cluster, and then it will run the actions in that. So just to cover up the time duration of creating the cluster, I will introduce you in little bit deeper with GitHub Actions. One second. Yeah. So yeah. So using MyData GitHub Actions, we can integrate the chaos experiments in GitHub CI, and we can have the number of experiments. The details are mentioned here. If you just want to follow these steps, uh, so these are the experiments that can be run, and there are the sample use case also, how to run the particular experiments. Yeah. The only thing here will be the environment variables that is to be provided for different experiments. And for knowing about the experiments and details, just go to the docs section and Litmus docs, and you will get the every information here only. So this is GitHub Actions actually. Sorry, uh, GitHub Actions, and from this we have one more feature that has been added with the CI point of view is GitLab templates, GitLab remote templates. So now we can use this remote template for integrating the kiosk with GitLab as well. I'm just showing you that also. Yeah. So now we are having a remote templates, and we can just use these templates in our CIs. Uh, we just need to add a remote variable, and we can use it from here only, and just have to append these variables with the values which we want to pass. Yeah.
Yes, Udit, you're audible.
Yeah. So any question around this?
Hello, Udit Bhaiya. I am Om here.
Yeah.
You said that we can take templates from any other place. Which type of object can we take, like a replica set, or like or all the type of template we can take and copy or just to run our
Mm-hmm.
for
Yeah.
to create our.
Replica set and deployments. Yeah. Thanks, Om. So the replica sets and the deployments. These are the types of. You mean this? These are the types of sample application on which you want to perform the chaos, right? So
Yes.
you just create in this. You just create this application in some of your previous stages, and in the 1 second again. Let me share. So and yeah. So just provide the application information here in the templates. So your application is in default name is what it is saying, which is having this label. And what is the
Yes.
kind of application you are creating, like deployment, replica set, stateful set, anything. And then the
Okay.
name of experiment which you want to perform along with its environment variable. So this is the way how it works.
Okay. We have to first create those and just
Yes.
okay, use like we have to use it like okay.
Yeah.
Thank you.
Yeah. Thanks. Any other?
Okay. Thanks, Udit, for the demo. Uh,
Thanks everyone.
if if, you,
Yeah.
if there is no further questions, Sanjay, are you there on the call, right?
Yeah, Jason.
Yeah. So you can go ahead with your demo.
Yeah, sure. Is my screen visible?
Yes.
Okay. Yeah. So you guys got the operator demo, right?
GitHub Action is the one which we went through now.
Okay. So are you guys familiar with the operator?
Probably you can just brief about the new feature and what is the new addition so that everyone is in the context. Okay.
Mhm. So you guys are familiar with the Kubernetes, right?
Yes.
Yes.
Okay. So here you can see we have two operators in the namespace Litmus. That is a chaos operator and a chaos scheduler. Okay. So chaos operator is doing the basic job of injecting the chaos, and what scheduler does will like automate the creation of engines that will be handled by the chaos operator. You can install the scheduler from here. We have a scheduler repo in our Litmus Chaos organization. So you can directly install the, first you'll have to install this RBAC file and then its CRD from here, and afterwards this scheduler. Here you can get the raw form of this file. Directly you can install this and the scheduler will be installed. First the RBAC file, then the CRD, and then afterwards the scheduler. So now we have a schedule YAML file. You guys are familiar with the YAML files, right? So this file you can also get here in inside the CRDs from here, cr.yaml. This file is available here. You can modify this and vary the nature of the scheduler. So what we are doing here is we are automating the creation of engines. This is the schedule field inside the spec. We have only just two fields inside the spec: spec.schedule and spec.engine template spec. So engine template spec is basically the chaos engine template, chaos engine spec inside the chaos engine CR. So directly you can put its spec inside this field, whatever engine you need to create. And inside the schedule field, we have these variety of fields, and like we can have from the type, we can change the nature of the schedule. We have total of 3 scheduling strategies. First is now, second is once, and third is repeat. What now will do is it will immediately create the engine. I'll show you. See, now we'll apply the schedule YAML file. So it has immediately created this engine, and this engine is doing its job by injecting the chaos. Okay, so this is what this now field does of the scheduler type. And afterwards, if we see the function of once, what once will do is it will inject the chaos only once, with similar to now. but at a specific time. So this specific time can be handled by this field, execution time. And this is strictly to be put in UTC time format, and the UTC time also. So if we see today is 23rd of May, and it's today's UTC time will be around 5. Current UTC time 5. See, Chaos Engine is also deleted because which just deleted the schedule YAML, and that schedule YAML was the owner of that engine. Now, if we try to put the schedule YAML file,
Just for the audience sake, like whoever is new for Litmus, what Sanjay is running is the pod delete experiment. You can see that the Nginx pod delete, it was running for like 2 days, and when you run this schedule now experiment, it got killed at 79, and now the age of the pod is like 79 seconds. And now after running the new engine also, or like new scheduler, it is getting killed and it's getting restarted. Now you can see the age is 14 seconds. Go ahead, Sanjay.
yeah,
Okay.
sure. So this you can see in the ones also we have created the schedule YAML file, and this Chaos Engine was created. And now we can see the third type of scheduling strategy, that is repeat. And in this repeat field, in this repeat type, we don't need this execution time, and rest all the fields of this schedule we will be needing in this repeat type. So what start time will do is we can have basically what repeat does is it schedules uh, uh, creation of chaos engines in a particular pattern. Okay, this pattern can be handled by all these fields. So start time and end time will be the range of that pattern. So when the chaos will be start injecting and when it will be ended. So before that start time, that chaos will not be executed, and after that end time, that chaos will not be executed. Between these two times only we can handle the chaos. And afterwards, if we see the min chaos interval, so we are injecting the chaos in a pattern, right? So what should be the minimum interval between the two chaos? Like if we are injecting a chaos at 5:10, so another chaos should not be injected until 5:20. So that will be the 10 minutes of interval between them. So like that, we have the min chaos interval. Instance count is we can put only one field between the min chaos interval and instance count. So if min chaos interval is handled, instance count doesn't need to be put here. And if instance count is there, min chaos interval doesn't need to be there. If we are giving both, just hypothetically saying, if we are giving both, so min chaos interval will be getting the priority. The scheduler will be taking care of min chaos interval and ignoring the instance count. So for now we are putting both. We can like comment this also, doesn't need to be there. And included days, what included days is like it will explain at what days of the week the chaos will be injected. So like Monday, Tuesday, Wednesday, week, today Sunday, so we'll have to add this Saturday. So Saturday needs to be there to inject the chaos. And now if we handle the start time 23rd May, Any question on the UTC time? If you're not getting it. Hello? I'm audible, right?
Yes,
Yeah.
Sanjay.
One question that when we change the type, actually, it will override the other time settings according to the type. Or how do we need to specify each time?
Sorry?
Can you open that file once again?
Yeah.
Here the type is actually, now it is repeat, right?
Mm-hmm.
So then now we need to specify the start time and end time, or we can
Right.
just delete the execution time.
Yeah, that we can remove.
Okay.
So it was just there to we can change any time from repeat to once, right?
Yeah.
So we'll have to add again that execution time, delete all these fields.
Okay.
So that is just for our easiness.
Uh,
These fields can be there, but just these will not be entertained from the scheduler.
Okay, just it will get override according to the type.
Yeah.
Sanjay, maybe it's better you can open that Litmus docs so that they can. So it is well documented.
Litmus docs, Ajesh?
Yes. Docs.litmus.
Yeah. You can get the function of all the you can get a scheduler manifest here, and scheduler demo is also recorded version is here.
And
You can
also,
afterwards see also. And chaos, this will be explaining all the functions of all the types of the schedule related and the chaos engine spec.
Okay.
So if you have any confusion, you can anyways ping me. And, yeah. So of the
you can try this, and in case of any queries, we can use the Slack channel for discussion.
yeah. So the repeat will be taking some time, it will be creating two chaos engines in the interval of 2 minutes time. You can see here. Yeah. So we have put the start time as 5:18, right? So that is the 10:48 of IST. Okay, so before that, no engines will be created, no events will be there, no status will be there of the chaos schedule. Once 5:18 is reached, we can see the status getting modified. See, field is added in this, and for now, like 5:18 is crossed, and we have put the 2 minutes interval. And one more thing, if we say we are having a 2 minutes interval, it will be according to the cron tab. So what cron tab is if 2 minutes interval is there, it will count from starting of the hour to the end of the hour. So 2 minutes will be every if we start at 4 and end at 5. So 4, 4, 2, 4, 4. These will be the pattern of the 2 minutes interval. If we put 3M, it will be 4, 4, 3, 4, 6. So around this time, it doesn't matter when we have started that chaos schedule or when we have put the start time. Only the chaos will be injected at these multiples of the 3M only. Okay, so 418 was crossed, and we have put the time interval as 2M. So next schedule will be created at 420 because since 418 was crossed already.
Basically, it goes as the cron schedule, right? That means it next will be at 520 UTC.
Yeah, yeah, right. It works as a cron tab.
Okay, so just a bit of highlight on this one. So till the 1.3 release, Litmus was supporting only the operator base, like schedule now, not the schedule, it's like immediate schedule only was been available. And due to the community request, like multiple uh, members in the community had requested for this the scheduler, even though they were configuring with cron tab. So that's how we decided, and as per the community request, we introduced this new feature as part of 1.4.
So you can see at exactly 10:50, that is the 5:20 of UTC time, the chaos engine was created. And afterwards, it will create at 5:22 since the period interval is 2M between them. And the two chaos engine will be simultaneously existing because one was already completed. So it will not hinder any injection of chaos further. So this engine is completed. You can see here. So this engine is completed. Next engine will be created at 22. Let's wait for that time.
In the meanwhile, do you have any questions from the team on the scheduler
Yeah.
functionality?
If any questions are there, I'll be happy to answer. So the second engine is also created. 3:30. You can see there is not much difference. 2 minutes 20 seconds was this age, and 19 seconds is this. So at exactly 2 minutes interval, the shipping engine, next engine was created. Yeah. So any questions are there?
Sanjay, do we have any randomness in the scheduler?
Not for now, Ajesh. We have to introduce our next feature will be there.
Perfect.
Are you building any APIs for this? Any API driven chaos injection?
API driven chaos injection. I don't understand your question.
For example, I mean, we are having to do a lot of things, right? Configure and work on a lot of manifests. So can we make things a little bit easier for example, layman who also wants to practice chaos? For example, some business analyst or any business person who wants, chaos to be injected, but does not know the nitty-gritties of or technicalities of it. How do we make things easier for them? Any web-based interface, anything?
Okay. Ankur, maybe like I can answer. I'll
Alesh,
take
you
this
take
question.
three
Yeah.
minutes.
So
Yeah,
basically, the
yeah,
litmus
Alesh.
is my voice clear? Or,
Yeah, Alesh.
yeah.
Yeah, yeah.
Okay. Ankur, so the question is on the API related things, right? So Litmus is been developed as according to the CNCF way or like the cloud native way. So that means like all the Kubernetes ways. So in Kubernetes, anything and everything what we write should be adherent to the CR, right? So basically, we have used all the specifications in Litmus using the custom resources or like custom resource definitions. So we follow that procedure, and this is the common way in the it's used in the Kubernetes world. So uh, any operations in Kubernetes, usually it's done through this way. And for your other question on the web-based thing, so the web-based part is typically not available and in the K8s world, and but usually what they do is like enterprise products will have built around this one, and which may have the API driven or like it's like the if it has having the web-based interface that we are working right now and which will be open sourced maybe like in a couple of months down the line we will have a complete web-driven Litmus thing.
Okay, you're saying that this enterprise products are already available for.
Uh, Currently, no, it is not there. It's like
Okay, but you are going to open source it.
we are going to open source it. We are working on
Okay, okay. Thanks.
Yeah, so this is the scheduler only. Any questions on the scheduler? If you feel like asking any questions later, you can ping me or visit the docs also. Here are the docs. And a recorded demo of the scheduler is also here. In the scheduler tab, you can go. And here is the scheduler.
Thanks, Sanjay. If
So
the
we are, yeah,
if there
yeah,
are no more questions on scheduler, probably we'll go with the next agenda item. Over to you, Rahul.
yeah. I'll stop sharing my screen now.
I'm Sanjay. Oh, okay. So, hi everyone. I'm Rahul. I've been working in Litmus team for quite a while now. Let me just share my screen, and my voice is audible, right? Everything is fine.
Yes.
Okay, great. Okay.
Yeah.
So we have. I'm audible, right? Okay. So we have been facing or asked by users many times, like, okay, so chaos, you're doing chaos, but how are you observing it, or how are you seeing a result of your chaos? And yeah, that was becoming a major issue because we were not doing any analytics part. So yeah, in past release we have been working over that over some stacks of Grafana and Elasticsearch and many other things which would help us get started with observability. So this is the new repo that we created in this release. This is Litmus Chaos Observability. In this, we are right now pushing many things, but yeah, I will show you the base of these things. So we have been adding some events, Kubernetes events. Like if you do get Chaos Engine, Litmus, and I have it engine, so Chaos Engine. We just describe this resource, and we will be able to see events. Not here right now, but yeah, there are some. This has been a stale engine, so yeah, there might be some issue. Okay, so what happens is for everything that you're doing, we are adding an event in this chaos engine. So for example, when we are starting the chaos, we are giving a chaos inject event. When we're creating the resource, we are doing some event and those things. So how do you monitor that now? you can't go and describe for each thing, right? That would be a hectic task. So what we have done is we have created this event router Loki, event router Prometheus and Grafana stack. Okay, this has a set of YAMLs that you have to apply, and the steps are also written over here. Like this guy is watching Nginx service as a default way. You can configure it to change something else. So what it does is it installs some resource on your Kubernetes cluster, uh, like this event router, this Prometheus black box exporter, and this Grafana code. So if you just check out the service right now, I've created it as a node port. I'm trying to see it on my localhost. So if I do localhost 1234, I would be able to get into this Grafana. Now what we do is we go into the dashboard. There's one dashboard created by Raj from our team that is helping us correlate service availability with service availability that is set to default service, this Nginx service. It is watching this Nginx service and then trying to correlate that with the chaos that we are doing. So let me just start a chaos. So what I do is I have this engine YAML. Chaos engine name, namespace, monitoring is true. So you get the events, app kind is deployment, app label, and app namespace, which is a default. Chaos service account and the experiment. Let's say I'm doing a pod delete now. As soon as I apply it, you will see some kind of a downtime in this chart because it's saying service availability is 1.000, but that would go down just because we are doing a pod delete experiment, and this that would try to kill this pod. That's it. Like that's the base of pod delete. Like so, if you're trying to ping a service, let's say I go into kubectl get service and do a curl request on the cluster IP of this port 80. We're able to see this Nginx, right? But what if we are doing at the time of chaos? In real life scenarios, your pod can go down anytime, or your pod can get evicted. Some kind of configuration error can be there. So how do you handle that? So we try to mimic that space, that area, and what we say is we will try to monitor your service also as well as while we are doing chaos. Let me just refresh it. So this guy goes down. Reports, Litmus. Yes, my engine is running. It is completed. Okay, I have to delete that. Sorry. Here's engine. Apply. Yeah, started it. Okay, engine is running. Let's just wait for that pod delete pod to also come up. Yeah, that's there. It's great. So it's running, and you would see some latency issues over here, service availability issues over here. So, and for okay, so this was for Grafana stack, and we have a similar thing for Kubernetes events on Elasticsearch also, and we are visually representing that on Kibana. So I have that. So I have these YAMLs and these steps performed right over in my cluster. So if you see, if I do kubectl get pods, and you see like Elasticsearch master Kibana is there, and this guy is also getting pod deleted again and again. So it's in container creating state. I check the dashboard. We would see some chaos start, chaos inject, availability 0. As you can see, it's visible, right? Chaos start time, inject, and so yeah. Okay, so yeah, so this is some kind of observability we are trying to provide over it. Kubectl get pods, Litmus, everything is running fine. Pod delete experiment got completed, so we are good to go. Then when we get into the chaos engine Litmus YAML, you will see the verdict as pass, execution successful, everything is completed. We are good to go. Okay, so now I will show you the Kubernetes events that we are pushing onto Chaos Engine in this Elasticsearch. So we have something called a metric beat. One second. Yeah, metric beat. Okay. If I show you the config map of this, so this is the extension provided by Elasticsearch, which allows to get the metrics of your underlying whatever you want to use. It can be a VM, it can be your own PC, it can be Kubernetes cluster, anything. So yeah, okay, get CM. You see this, I have some auth related data, Elasticsearch output, and these things as environment variable. And okay, that would be a separate config map. So there I have hard coded it to just get the events. We can get a lot out of that, but right now we are just getting the events. CM module, Litmus, YAML. Yeah, so you can see the metric set is event. I'm saying the host is created as events. Period is after each every 10 seconds it will try to ping it, bring the Elasticsearch index and then push the events. Okay. So what I have done in index management is that I'm getting this metric beat, this index. What I've done is, if I go into my discover place, what you will see is we have added this filter, use metric beat, and you can see there are various events getting presented over to us. So what this event represents, okay, so these are all the Kubernetes events. So we add a filter, we say let's add a filter, let's say we want to do involved object. I'm not sure to see the full name, but yeah, there would be something called as involved object type. Involved object type, okay, and is select the value. Okay, let's say v1 alpha 1. That's great. We are getting it via the API version. Okay, so involved object, so unable to get chaos engine, and there are various events that you can see over here. So we are doing some kind of event generation in our code that are visible to you guys here. Yeah, chaos operation failed, some kind of we are logging into every kind of events. So if I just do it as times time, just add this. So as you can see, yeah, these are all the experiment job. Pod delete will be retained. It's unable to get chaos engine. So this would be an error message that we are also adding. Injecting pod delete chaos and then pod, yeah. So we are adding this Kubernetes event that are visible to you guys. So we have a few more stack available here which I have not shown in this demo. One is this Loki Grafana. So what it does is in the Grafana dashboard you can all view the Kubernetes event and then filter out via JSON filtering this to get all the events of Chaos Engine. And as shown the metric beats one, there is one for logs also. All the logs that you're having in your cluster that would be aggregated via this. Litmus job is equal to Litmus pod deleted, so you can see all the steps performed in Litmus pod delete experiment. Yeah, so you can just head over to this repo and check out. We have attached all the screenshot over these, so yeah, it would be a little easier to understand. That was all from my side. Do you guys have any questions? Okay, great. I think everybody's clear with that part. So I think Shubham, you can continue.
Okay. Hi, I am Shubham Chaudhary working in the Litmus team. Let me share my screen. My screen visible, right?
Yes.
So I am going to discuss about the Litmus Go and Litmus SDK. So I mean, we have Ansible experiment in the Litmus repo. For example, we can see here. Yeah. So here we have Ansible experiment. Now we are also creating the Go experiments. I will discuss about why we are creating the Go experiment because of about the speed. Because the Ansible is an scripted language, so it will take some time to execute the task. So Go provide a faster way to execute the same task. And in the Ansible we have some limitations about looping and all these things. So all these things can be covered by the our Go experiment. So because this is in the alpha version, so we only have one experiment this time, pod delete in Go. So I will give you a demo about this Go experiment. So I have a 3-node cluster. One master and 2 worker nodes. So first, we have to create the CRDs, our custom resources. But I already have. Let me verify. So we have all the 3 CRDs, custom resource definitions: Chaos Engine, Chaos Experiment, and Chaos Observability. So after this, we need a RBAC, for the service account and all the permission to access the cluster. So I have already created the service account and all these things in my namespace. You can see Litmus is my service account. I have also, I'm using Nginx as my application to inject the Go pod delete. So let me first create the chaos operator, which is a reconcile function. It will reconcile to the chaos engine. So it is in container creating state. Yeah, it is created. Now let me create our pod delete experiment. So this is the pod delete experiment CR custom resource. So everything is same. In the Ansible also we have the same custom resource. The difference is about image, because this is the different repository, and about the entry point. There we are using some Ansible playbook, and the playbook file. Here we are directly passing the binaries of the same experiment, and other things are same. So let me apply this. So it is created. Let me apply the chaos engine. Let me check the value. So here we can provide the override the image also for the chaos runner. Here we can provide the application info. So my name is Species Shubham, and application label, we can verify the application label. So our application labels are run is equal to Nginx. We have already provided run is equal to Nginx. It is a deployment. Service account is Litmus, and the name of experiment body. Yeah, everything looks fine. So let me create our chaos engine also. So after creation of chaos engine, the chaos operator create a runner pod, basically which uses the envs from the engine and experiment all the values and create a final our pod delete pod. So this is the main pod which actually do chaos. So we can verify here. You can check the Nginx. So it is already deleted one time. So I applied for the 2 iteration. Now it is deleted again. You can see it is in a container created state. let me wait for the completion of the pod delete chaos. I mean, it has some pre-chaos, post-chaos check. Now, yes, now it is completed. We can verify the result from the chaos result CR also. So we can see it is passed and completed. So we can verify, and if there is some fail step, if it is failing, we can also get the fail step here. So as Rahul discussed, we have some events in our chaos engine. So let me show you the events also. We have total 9 events. So we can see all the 9 events here. I mean, the type, I mean, the reason, I mean, the why we created this event, the is and the from and all these things, the main resources which created this event and message. So we can, and here, I mean, if the events occur multiple times, it will also, I mean, add the count, I mean, 2x or 3x or whatever. So this is only about the experiments. I will show you, I will tell you about how to contribute the experiment, how we will create a new experiment. But before going to that point, we can, if anybody have any questions, they can ask.
Shubham, for wider community, I'm just asking, why do we want to use Go instead of Ansible? So what is the advantage we can get it from here?
Actually, I already mentioned. I mean, there is something about speed because Ansible is a scripting language, so it is take more time compared to the Go. First point is this, because the Go executes very fast. Second point is about, in Ansible we have some limitations. For example, looping. If we want to loop, I mean, it is not providing a good features about loop in Ansible. And I personally feel that I mean, in Ansible we have some looping, because I also face the same issue multiple times. So Go is better in that way also, and Go is more flexible language than Ansible. I
So
mean, Ansible is easy to learn, but
this will help developers to contribute better. Is that
yeah.
a right statement?
Yes, yes. Okay, so let me show you how we can contribute. So in contribute/developer guide, we have all these files. So we have attribute.yml.sample. We can create a new file. I mean, this is the sample example. We can create a new file from this, or use the same file. So let me create a new file from this. Say attribute.yml. So here we can provide all the information which we need. This is the single source to create the experiments. So basically we can provide all the necessary information here. For example, name of the experiment, version. In the beginning, normally we put 0.1.0. What is the category? I mean, currently we have generic, Kafka, Cassandra, OpenEBS, all these categories. So if this experiment belong to the same category, we can provide that category. Otherwise, we can also provide a new category. And the repository, I mean, where it will be there, community, I mean, Slack link and description, keywords, scope, name scope or cluster scope, permissions. We can provide all the permission which will be needed by the service account to access the resources. I mean, and maintainer's name, contributor's name, all these things, Minikube version and all. So let me apply the same thing, because this is just a sample. So we have a Python script to generate this for this time. I mean, this is an alpha version. After it, I will tell you, I mean, how we are planning for next. So here we can provide the name of our file. So my file name is attribute.yml, and generate type can be experiment or chart. I mean, chart will only create a experiment CR and CSV. CSV is basic CSV file. CSV is basically a metadata about experiment. But if we provide experiment, it will create the all. So let me create the all. So it has all, everything is created. Let us verify. So here, this is the CSV file. I mean, the metadata about experiments, name, version, category, repository, and all these things, display name, and all these things. So it is created. If you want to modify this file, then you can modify. It is template. This is the package. Package contain all the list of the experiments and details, so that we can display in the chart hub. We choose sample category, so it is create a sample category. Inside we have a pod delete. So this is the chaos engine sample for the same experiment. This is the experiment CR for the same experiment. I mean, all the permission image and all. This is the job. I mean, there are the two way to execute. For this time, there are the two way to execute an experiment. We can provide the value directly into job, or we can use the chart and chaos engine. All this is the I mean, this was the CSV for the category itself. This is the CSV for the experiment CR, and this is the main file, our poddelete.go. So this file have main three sections: pre-chaos check, main chaos injection, and post-chaos check. So in pre-chaos check, we have, I mean, application status check as the default space, main application and auxiliary application status check. Auxiliary application status are the dependent applications. Or if you want to add more status check, for example, data persistence and all checks, you can add your logic here. I mean, I have commented all these things. Here you can include your chaos lib. I mean, the chaos lib is which contain the main business logic. So you can include your file here. Post chaos is same. I mean, status check as a post chaos as default one. If you want to add more, then you can add here. And this is the RBAC file. So you have provided that values in the, I mean, permission, all these things in the attribute.yml. So it is generated the RBAC file, which is need for the creation of service account. And inside our chaos lib, we have, I mean, it is created this chaos lib. So I have just created a dummy chaos lib. So you can provide your details, or you can write your business logic here. I mean, if you want to use any existing chaos lib, then you can include that invoke that directly from there. If you want to create the new one, then you can make the changes here. So I mean, because this is an alpha version, so these are the only way to generate the files. After that, I mean, we are making it more mature. For example, we can directly use operator SDK, I mean, Litmus SDK command to test it. I mean, by providing the kubeconfig file directly from the command line, and we can generate the file directly by that command. But this time we are using Python script for this. So and I have added all the information in the README file also. You can get some idea here also. So I have added all the information here. I mean, how to get started with this. So this is only about how we can create a new experiment. Any questions, any doubt?
Thanks, Shubham, for your demo.
Okay.
Okay.
So thank you, everyone. I'm stop sharing my screen.
So we have covered the planned agenda items for today. So we'll open it for the floor. Like if you have any specific questions on the contribution or like how the usage of Litmus, probably we can discuss right now for a couple of minutes, and then we can wind up this call.
I have a question. So currently the demo or the parts which we store is only related, pointing to the Kubernetes objects only, right? CRDs and the objects and all. So is there any plan to implement chaos strategies for physical resources level also, or like the memory, network, IO, in that kind of level?
Okay, so that's a good question. Probably let me share my screen.
Yeah, I'm asking this specifically because I was able to see one demo for VMware Mangled 1 week ago. So they actually showed some those kind of things and all in that tool. So I'm just trying to compare.
Yeah, correct, sure. I'll just try to cover a little bit on this thing. So we are concentrating mostly on the application side, and we have planned to do the infrastructure side as well. So there are like some experiments which will affect the whole infra. So let's say the hub is the main part of the, it's like the user interfacing part, which will show you which all experiments are available from Litmus. This is a place where the developers or the community can contribute new set of charts to here, right? So we are completely open source, as you know. So these are like, say we have application specific chaos, like for Cassandra or the Core DNS or Chaos Toolkit. These are or Kafka or OpenEBS. Let's say these are the things which we have right now, and we go to generic chaos, which is basically the uh, these are the experiments which are available for generic Kubernetes objects. So, so this, if you go through this one, so there are some experiments which are having this star mark on this thing. So this indicates that the blast radius will be for the entire node of the system. If it does not have, that means the blast radius is with respect to the that application. So like we have experiments like node CPU hog. That means like the entire CPU on the system will be affected. So by running this, so and disk fill is one which will affect the uh, disk of means like whatever ephemeral disk we are going to use there. So it will fill up the things, so it can impact other applications as well. And similarly, the disk loss, so is the one which will affect the entire thing. The node drain will affect. It's like it will drain the nodes, and it's like it will try to evict the applications in that node, and it so that's a way. And similarly, the memory hog will affect the entire system memory of the system, which means like you will be running against that application, but it can have an effect on to the complete thing. Is this the question, Sabin?
Yeah, this was.
So as said, like we are mainly concentrating on the application level, but we have the infrastructure things as well. So it is like pretty straightforward to integrate into, and it is like open things. Like if you have more things which we want to contribute, you can contribute here. And this like the network loss and all we are doing as of now with respect to the uh, application only. So we are not restricting the things for the entire network, but it can be you can write it pretty easily with the same logic.
Okay. Thank you.
Any other questions? Okay. Thanks for your time on a Saturday, and hope you have got some benefits on this one. And I would like you to reach out on this community. And thanks, Rajdeep and others who you could see like earlier there was one more person had joined the call. We'll wind this call and see you. We have this online meetup every third Saturday, so we'll keep it posted on the meetup page, and we'd recommend you to join. Thanks a lot, and bye from today.
It was a great session. Thank you.
Thank you.